Alright, now that you saw that cool demo on how to hack that software, let's go over what just happened. Our input overrides the program behavior. It made a transfer to return money from CheckPass instead of the original main that was supposed to be the next step from CheckPass. What we did is we found the address of transfer money by reverse engineering the program's binary code. That's a key skill in hacking, reverse engineering binaries and other obfuscated codes. We then developed an exploit using Python to do our bidding. A more complicated exploit could do many interesting things. Instead of just running transfer money, you could download malware from the internet and run it on that machine and give us unlimited access to that machine and let us control it for an infinite amount of time. So a typical malware usually remains on a machine for 3 months to 2 years. Now let's define vulnerabilities. As we saw before, software has bugs, and some of these bugs can be exploited. So it's important to know that not all bugs can be exploited. But we don't really know which bugs can be exploited, and that's the risk. The bugs that can be exploited make software vulnerable. So that would be a vulnerability or a vulnerable software. Exploits rely on many assumptions to work. For example, the operating system, the program version, the environment, and many other things. So in the example that we saw, we had to run this code on a carefully controlled environment and on a particular operating system to be able to hack it like that. The bug would still be hackable in many other situations, but the addresses that we would have to add in that Python code would be totally different. So the same exploit would not work. And even in some situations, it wouldn't be exploitable at all. So not all bugs are exploitable. That's where reliable exploits come in. Software has a billion different configurations. Operating system, hardware, version, etc. Each software runs in a million different settings and million different configurations. A basic exploit like the one that we just saw only works on one configuration. A reliable exploit, on the other hand, first detects the configuration, then adjusts the payload to work on the new configuration. And that's why a reliable exploit is much more likely to work, and that's why it's also much harder to make. It takes a real good hacker to create an exploit, but it takes a village of hackers to make a reliable exploit, and that's why they cost a ton more. So how do we defend against exploits? There are different methods for defending against exploits. Some systems, such as the operating system, have automated mechanisms such as the address space layout randomizations and data execution preventions, or stack canaries. All of these are automatically used by the systems to make hacking harder, if not impossible. So we had to disable at least one of these in the example that we just saw to be able to hack that software. But even if they're in place, the software is still hackable. It's just that the hacking is much more complicated. Also, on top of the system features, programmers use a variety of tools, such as testing and debugging tools, to make the software less hackable. And once a bug is found in a software, they release and update that software, which is called patching. They fix that vulnerability by patching it. But the bugs are never gone for good. By fixing bugs, we just make them rarer and harder to exploit. And then we hope for the best. So as time goes by, as the technology advances, hacking becomes more difficult and thus becomes rarer. So we hope that the hackers that actually can still hack software don't come our way.